Properties of graph of functions. Sketch a graph of all possible transformed parent functions which will not contain the point 1, 1. Let's try to explore this situation. So that's our coordinate plane, and let us say the point 1, 1 for us is kind of here, right? That's the point. So we need to sketch graph of transformed parent functions so that they do not contain this point 1, 1. Now let us consider a straight line which is y equals to x. Now if x is 1, y is 1. If we want to avoid this point, then we can consider y equals to 2x. That means vertically stretched by a factor of 2. So in that case, we'll go from 0 to 2, right? So a line which will be like this will not contain the point 1, 1. So that's the whole idea of this question, right? So it's a simple question, but it's interesting, and you need to understand it. Now let us say y equals to x squared. So what we can do is we can consider a function like y equals to minus x squared, right? In that case also we'll avoid the point 1, 1, correct? So we can have the graph, it will go to minus 1, right? So kind of like this, right? Going through 1 minus 1, right? So that is how you can transform your functions and ensure that the point 1, 1 is not on them. For example, y equals to absolute x. You could translate it left or right, correct? So if I do y equals to absolute x minus 1, for example, so I'm showing you different ways of doing it, then the graph will be like this, right? So the absolute transformed function will also not contain the point 1, 1, right? Now if you are considering reciprocal function, which is y equals to 1 over x, right? Now here also the horizontal and the vertical asymptotes are along x and y axis. So what you can do is that you can translate your function so that you have vertical axis along x equals to 1 and horizontal axis also along y equals to 1. In that case, the graph will not contain the point 1, 1, correct? So these are so many ways to do it. Well, for all these situations, we can have many different solutions, right? There is not a particular solution which fits into these, but there are so many ways you could do it. So what I've done here is I've written a function where I've translated the vertical axis to 1 and vertically we have transferred one unit up, correct? So likewise we can do for all the parent functions, right? If you have y equals to sine x, for example, well, sine x does not really contain the point 1, 1, but we need to draw a possible transformed function, right? So what we can do is we can draw y equals to minus sine x, right? And sine x will go kind of like this, but we could have going downwards, correct? So something like this will avoid 1, 1 in this case, right? So likewise we can draw all the parent functions as transformed functions and avoid 1, 1, right? One more to go, and that is we could say y equals to square root of x. Now square root of x will go through 1, 1, but we can translate it 1 unit to the right. So if I translate it, so it becomes y equals to square root of x minus 1. In that case, I have a graph which is kind of like this, right? So likewise, you've seen that we can always translate the graphs to avoid a point. I hope that's interesting for you. Thank you and all the best.